All right, we're back for our last set of notes for calculus. Isn't that crazy? You guys actually already did this last time when we covered the disk method. It's just more formally called the washer method. So a disk, obviously, when you're finding, let me find my notes from last time. When you're finding, if it's a solid, right? When you slice a piece of this, if I looked at it and turned it front view, it would be a solid disk. Right? We talked about those. Sometimes there are, it can have a hole in it, right? So that you had to subtract out that shape in the middle to actually find this volume. That's a washer. That's what a washer is. This shape right here, a circle with a hole in it. So we've already done this. It's just more formally called the washer method. And we're going to do a couple more problems that are a bit more complex, okay? So, just like you said, sometimes it doesn't come out solid, that thing you're rotating. It has a hole of some type. This arises when the area that is rotated in the area between the two functions rather than just beneath one function. So really it happens when you have two functions like this and you're finding this area, right? No matter which way I rotate that around the y or the x, it's going to have a big hole in the middle. So here's another picture. You guys can read through this. I'm not going to read it to you. This is exactly what we found out last time, right? To find the volume by slicing that shape into smaller and smaller washers, you can integrate from a to b pi r squared. But what's your r? It's just your outer minus your inner again, right? This is your outer radius minus your inner radius, pi r squared. So let's try some. And like I said, we've done this before. So we'll be a bit more practice with the same thing, a little bit more complex. This is find the volume of a solid of revolution generated by revolving the region bounded by the graphs of y equals 2 over x and y equals 3 minus x about the x-axis. Okay, remember this? That means I need to integrate in terms of x, since we are rotating it across the x-axis. So I'm going to draw this just because I need to imagine what this looks like. Y equals 3 minus x. I can do that. I'm going to rewrite it in slope-intercept. It's minus x plus 3. So I have a y-intercept at 3. And then my slope is down 1 over 1, down 1 over 1, down 1 over 1. Something like that. Okay, that's y equals 3 minus x. All right, and then what's my other curve is y equals 2 over x. Okay, so I know it's y equals 1 over x times a dilation factor of 2. To make my life easier, I'm just going to find some intersection points. So let's find these intersection points. So when does 2 over x equal 3 minus x? All right, so 2 equals 3x minus x squared, which means 0 equals 3x, let me rewrite it like this, minus x squared plus 3x minus 2, which then I'm going to rewrite as x squared minus 3x plus 2, because now I can factor it as x minus 1 and x minus 2. So x equals 1 and x equals 2 are where they cross. So x equals 1 is here, and we can see that that works. If I plug in 1, I would end up with y equals 2. And then also again at x equals 2, if I plug in 2, I'd end up with 2 over 2. It's at 1, which is exactly where it's at. So really I want to zoom this in where something here is happening like this, right? My drawing's not very big. So we have this little slice here that's bounded by those two. So my picture from last year is a lot bigger, so that might be easier to see. I made it too small this year. Y equals 2 over x. Okay, that just helps me get a general idea, and it helps me find the bounds. So we know the volume is equal to pi integrate. Well, we're integrating in terms of x, so we're going from x equals 1 to x equals 2. And then we need our outer radius squared minus our inner radius squared. So what is our outer radius? Well, it's this line, the line of 3 minus x squared. minus the inner radius is the curve here, 2 over x squared, all times dx. Okay, so now we're just doing arithmetic to solve this. So this is volume equals pi from 1 to 2. This ends up being 9 minus 6x plus x squared. This ends up being 4 over x squared, all still times dx. This is just equal to 4x minus 2. So then when I combine them, that's volume equals pi times, all right, I'm going to start with the x squared first. So that would be x cubed over 3. And here would be minus 6x squared over 2, which is just 3x squared. Do I have an eraser? Here we are. I'm just going to make that 3x squared because that's going to be easier for me to think about. That's going to be plus 9x. This is going to be minus 4x to the minus 1 over minus 1. So that means this becomes plus, and this really becomes 4 over x, right? All evaluated from 1 to 2. Okay, so then when you plug those in, I'm just going to write what I got last year to save time. That's 8 over 3 minus 12 plus 18 plus 4 over 2 minus 1/3 times, sorry, 1/3 minus 3 plus 9 plus 4. So you can check all that if you want, but it ends up being pi over 3 cubic units. So just like I said, nothing too different from what we did last time. It's just if you're dealing with a washer method, it's always going to have a hole. And you can imagine this little shape, if it's getting rotated around the x-axis this way, it's going to have a giant empty space in the middle, right? From 1 to 2, all of this is going to be empty space. All that blue. Okay, let's try one more. Example 2, this says, find the volume of the solid of revolution generated by revolving the region enclosed by the graphs of y equals 2x and y equals x squared and the y-axis. Okay, so now we need to use y-bounds. Oops. Hey, I'm making a video.
Huh?
I'm making a calc video. Mr. Sharp's making an appearance.
Hello.
All right, so we need to use our y-bounds, so we need to graph this first. Let's sketch what the graph looks like. So we have y equals 2x, well that's a line. Y-intercept is 0, slope is 2. So up to over 1, up to over 1. Okay, so let's just quickly sketch that. Y equals 2x, but remember if we need to integrate in terms of y, we could also write that as x equals y over 2. Okay, there's the first line. All right, the next one is just parabola y equals x squared. So we know it's going to intersect here at 0, 0, right? So if you want to find your intersection points, you could just set that up first to find them at intersection points. When are those two things equal? So when 2 equals x, right? If I divide each by x, but also you could have done this, and you know that's going to be true also when x equals 0. So that's why we have that point, and then at x equals 2, the y value is 4, so they're intersecting there. So my parabola is something like this. Here's the space in between. I shouldn't be going in, I should be getting wider. You guys should actually be going like this, if I'm drawing it correctly. Right, but this is just a sketch for my brain. Some people don't need to sketch. They can just figure it out by just looking at only numbers, but I like to do this. And then we also know that means x equals root y. So there's our space. We're integrating this way across the y-axis. So what does that mean? All of this stuff is empty space. Okay, let's set up our volume. We know it needs to be pi, and we're integrating along the y-axis, right? So we're integrating from y equals 0 to y equals 4. All right, so what's our outer radius? Our outer radius, if we're integrating across the y-axis, Mr. Benayak, can you close that door? I'm recording a video. Mr. Benayak, can you close that door? It's really loud. Okay, so the outer radius is this right here, right? Because we're integrating this way across the y-axis. So we're integrating in terms of y, so we're going to have root y squared. Minus the inner radius is this. That's going to x equals y over 2 squared, and then dy. Don't forget to write these dy's, dx's. If you forget to put that in your on your exam, you'll lose notation points, okay? So let's keep going. Sorry about all the distractions today. Everyone just feels like they can walk in the room. All right, what is square root of y squared? Well, that's just y. What is this? Y over 2 squared ends up being y squared over 4, and that still has a dy. Now we're just going to integrate, come over here. Volume equals pi, y squared over 2, minus y cubed over 12, right, when I multiply 3 times 4. Evaluated from 0 to 4. What does that equal? Pi. Okay, when I plug in 4, I end up with 16 over 2. And then when I plug in 0, I end up with, 16 over 2 minus 64 over 12. And then, so I'm going to do this. When I plug in 0, I end up with 0 over 0. And when you evaluate that, it ends up being 8 pi over 3 cubic units. Don't forget your units. This one doesn't tell us what the units are, so we just write cubic units. Okay, just like I said, this is really just building on what we did last time. Nothing new, just getting a bit more complex. Can you believe you've done all the calculus material now? You've at least heard it. Now let's see if we can put it all into action here in a few weeks. All right, I'll see you next time in class. Bye.